Hey, this is Roger Hannegriff here with the Agribusiness Sector, and what we're talking about today is time value of money and using some applications called net present value and internal rate of return. So let's get right to it. Remember, be an active learner. Take notes along the way with me. I'm going to work through some problems today and just give you a summary of those results. And then I want to jump over to Microsoft Excel and show you how you can actually do the work. But it's first important to understand the concept. So let's look. All right, so we're talking today specifically about a concept called net present value. So write that down with me. And internal rate of return. All right, and so this internal rate of return and net present value are really described usually as NPV for net present value and IRR. And so this is something we're going to do as an example. We're going to work an example. But before we do, we need to review a little bit. So let's talk a little bit about some concepts that are important. Remember, in time value of money, we are talking about terms like present value. And let's write that up here, present value. And that is trying to find the value at today. That is present value. Future value is the other way to go, and that's trying to say, okay, I understand what it's worth today. What's it worth in the future? So the future value is the value at the future. Now, these are pretty simple concepts. These are the concepts of time value of money. So that's kind of what we're using. But I really want to focus on the present value one because that's probably the one that's used the most, and it's probably one that definitely is a tool that relates to our examples here. All right, so let's talk about what is present value. And in its simple form, I'm going to change my pen here, but in simplest form, in a formula, easiest way to identify it is the present value is some future value of money discounted or divided by 1 plus some rate of interest to the nth power. And remember, we've talked about this in your other concepts, but I is this idea of rate and N is this idea of time. So if we are saying to ourselves, I want to analyze an investment, is it a good idea to spend $100,000 to put in a new grain bin, for example, to sell feed corn out to deer hunters to use in their deer stands? Possibly that's like a business idea. So let's say, is it worth it to put a $100,000 investment in, and what income am I going to get out of that? So that's a great example of what we call net present value and internal rate of return. We're doing analysis. To do that, we need to understand present value. In other words, if you're going to put $100,000 out there, the present value of that is $100,000 because there is no time, so therefore that's zero. So this whole thing goes away. It's just whatever your number is. So if you say you're going to spend $100,000 today, that's $100,000 in present value because it's today. But if you say you're going to get back, let's say in the first year, let's think you're going to get back $10,000 from your business here in this idea, that's a year from now. So now this formula starts to help you. Now, time would be 1 year. Now, what is rate? Rate is this idea that our money does not sit idle. It shouldn't. It ought to be invested and ought to be working for us all the time. So that rate might be I could have taken my $100,000 and invested it into, let's say, a bank investment account or a bank CD, which would earn me not even 1%. So that would be a super cheap rate. What if you could take your $100,000 and you alternatively could invest it in some other business you have going? And that business generates you 10% return. Well, now the rate's 10%. So the idea is that money's not free. So that's going to be a rate we're going to use. Whatever we think we can earn in other alternatives, that's called opportunity cost. Whatever we think we can earn in some other alternative, plus whatever time we're talking about, that affects present value. So as you can see, without getting into this too much, as time increases, what happens to present value as a question? So if you've got to wait longer time, then present value is going to go down because this whole part of your equation just keeps getting bigger. Because it's whatever that rate is, exponentially pushed out to 1 year, 2 years, 3 year, 4 year. As you keep making that number bigger, that drives down what that's going to be worth. What about your rate of interest? If your opportunity to earn money in other places is big, that's also going to make that larger. That's going to drive that down again as well. So the idea with time value of money is that present value is a great thing to try to understand, especially if you're talking about putting in a $100,000 grain bin and it's going to generate you money in year 1, in year 2, in year 3, in year 4, all the way out to, let's say, 10 years before it needs major repairs. Then that is going to be a great time value of money of question when we're trying to calculate what's the present value. So the idea is basic. If you spend $100,000 in today's money and you bring back present value in today's money, present value worth $105,000, then you have covered all of your potential income you could have made in other places. That's what I was looking at. And you've covered the 10 years worth of time, and you still have money left over. That means that this investment must be a good idea. So that is the concept of net present value. It uses the present value calculation put together with a cost and see if it's worth it. Now that's the idea. That is the function. What is an example? And then we're going to look at how that example is actually calculated. But let's look at an example first. So I'm going to start off with how do you set up a net present value table and how do you set up IRR along with that? Well, let's start off with the net present value. To do this, you need something we've already talked about. You need a concept of time. Time is going to start off at 0, which is always going to be today, and it's going to go to 1, 2, 3, 4, and I've got a simple example out 5 years. All right, so that is the table that we start to set up with. The next is going to be our cash flow. Now, in lots of problems, this gets looked at in lots of different ways. It kind of makes this sometimes hard to do, but cash flow is just the money. So there is some net value that you're going to get to. Now, you don't want to really always talk about gross because you've got expenses, but what money are you going to get back? Well, the money that you start off with is going to be listed here. So, for example, in the example I have for you right now that I'm going to work out later, my example is you have to spend $100,000 to put in the grain bin. That's what you spend today. Notice how I put the negative in front because that means that money's going out. Hopefully, the money we bring back in makes it a worthwhile investment. Well, the money that you have is not all you need. You also need the present value dollar of that, which is going to use some things. Time is one that we need, and I'm going to put in here the opportunity cost rate. That is that I was mentioning over here in this formula. But let's say that we could earn 5% on our money in other places. And so that's what our alternative is. So you could take your $100,000 and go get 5% and make some money, or you could invest $100,000 in this grain bin, and let's just see if that is a good idea. And it really depends on time, the factor, and the money. That's right over here. There's your time, there's your factor, and there's your money. And so this is a simple concept of taking present value and putting it into a practical application. All right, I already know the answers to these because I've calculated these values. You would typically in a problem either be giving these cash flow values and calculate the present values, or you would, and then you would use a formula or a table, or you would use Microsoft Excel, which is what I'm going to impose on this screen here in just a bit. But I just want to go through the concept. What does it mean? Because that's important. How to calculate it, I'll show you that too. So I've already calculated these numbers, and in year time value today, you pay out $100,000 in cash to get these grain bins built, for example. Now in year 1, your business brings you back $12,500 in my example. In year 2, your business brings you back $22,000 in my example. And in year 3, our business is growing. We get $25,000 back in our example. And then in year 4, we get another $25,000 back in our example. And then in year 5, we get another $25,000 back in our example. Now, if you're looking at this and adding this all up, it looks like we've got 25, 25, 25. And then if you add these two together, that looks like, what, 34,500. So if you add all this together, we're getting way more than $100,000 back. But what's the problem? The problem is you got to wait 5 years. So really the way to analyze this is not to just look at the whole numbers, because they're not really telling you everything. That $25,000 5 years out is not worth the same $25,000. It's worth a lot less to me. Why? Because I could have used that money to earn 5% somewhere else, and I also had to wait 5 years to get that done. So what you have to do is calculate present value. And I'm going to show you again how to calculate that. That's also a topic we covered before in a different area. But let's just give you those numbers. So what's the present value of $100,000 paid today? It's the same $100,000. There's no discount to it because we already talked about that. There's no time and there's no rate then. The rate doesn't matter if there's no time. What about $12,500? If you got to wait 1 year out, I've calculated that already. It's $11,904. That's what that's really worth. So you start to see the idea about this. If you've got to wait a year to get 12,500 today, that's worth $11,904 to you. All right, what about 2 years out? You got to wait to get $22,000. That's $19,500. I think that's right. $954. Kind of messed that up a little bit. So $19,954. All right, $25,000. You got to wait 3 years to get that. That is $21,595. And again, we're just talking about concept here. Don't get too caught up on the numbers. We'll show you in a second. $25,000. You got to wait 4 years. Now, 3 years it was worth $21,595. What do you think it's going to be if you've got to wait 4 years? You got to wait another year to get that. That's going to be $20,567. All right. Then finally, in your last year, year 5, that's $19,588. All right. So what is net present value? It's really just a simple concept of the total of all the present values that you have calculated. So really, you just total this whole thing up, and what you're hoping for is a positive number, but in this case, 6,388 with a negative, so that's why I've got the bracket in front of it. That's a negative net present value. So you would look at this and you would say that this is a bad decision based on these values. In other words, you're putting out $100,000, and if you got to wait a year, 2 year, 3 year, 4 year, 5 year, if you add all this up, these positive values right here that I just added, they're the good stuff. That negative value up there is what's holding this back. That's 6,388 to the negative. It's bad. When would you have a good net present value? You'd have a good net present value if you could get a positive value. So what's a good net present value? A good net present value is equal to a positive number. Now you might say, hold on a minute, what if you just had this to be positive by like $500? So a plus 500 right here is good? The answer to that is yes, because don't forget, you've already earned whatever you said your rate of opportunity is. So if you're saying, hey, if I got 5% on my money in some other alternative, that's what I could do with the money. But instead I put it here. So really the question is, does this give you back any extra? And if it does, that's going to be a positive NPV, and that means that's a good idea. Internal rate of return is another calculation that helps in this whole conversation. Internal rate of return is the rate that this business model is earning. Remember, the opportunity cost was 5%. That's what the opportunity was. But IRR is going to calculate what the actual return is. And that's best done in a calculation in Excel. And so I'll show you that in just a second. But the IRR of this, because it's negative, we do know something just by trying to make sense of this. If this whole deal is negative, that means it is earning less than what I required it to earn. In fact, the IRR of this is 3%. And so when you compare the IRR to this value right here, a good decision means this is higher, but that's also going to mean the net present value is positive. A bad decision is this is lower, which also relates to, we already knew that, we had a negative net present value. So that is the concept of net present value. It's really a practical application of present value put into a capital budget is what this is called, where we look at capital outlay of money, the returns that might relate to that, and is it a good idea or a bad idea? Simply by using the present value formula, totaled across all the years, then add it up, and you're looking for the number to be positive. The biggest difficulty I think here exists is that when net present value is some small positive $500, a lot of people say you're only making $500, but they're forgetting that the net present value calculation has already factored in what you said you needed to earn. So if you think 5% is not good enough, if you think 10% is better, 12% is better, then you're just simply going to be driving down those PVs and making this thing earn you more money, or try to see if it will make you earn more money. The answer in net present value is going to tell you if you have any extra left over. So the higher you make that rate, the lower you drive present value, the more difficult you make it be to pay that high cost off. But if the investment is super risky, then that makes sense. But net present value is just a calculation using present value to determine whether an investment is good. If we were looking at this in our example, $100,000 paid out today, this is the income you think you could bring in from hunters buying your deer corn, then that by itself is not going to fly. You're going to have to figure out how to build the grain bin cheaper. You're going to have to figure out how to maybe run this business longer. My simple example, that's really the problem. Only 5 years out for a $100,000 investment based on this money back doesn't really work out. So you need to run this for a longer period of time. So there's lots of ways you could make this work out. But that's the concept of net present value. Let's take a look at Microsoft Excel and how you calculate these numbers. Okay, here we are looking at the same problem that we worked out on our board, but I want to talk about here, how do you use Microsoft Excel to actually solve this present value calculation so you can get net present value by adding them all up. I've got the same example that we have here, so I'm going to stay on the screen here but show you my work as I go. Now I've set this up just like we did on the board. I've got opportunity cost at 5%. The initial investment's $100,000. Time value 0 is that $100,000. What I did was just pressed equals, grab that number, put a negative in front of it so that it gave me that negative value I needed. Then in year 1 through 5, I added in the same exact numbers that you had on the board, except as we talked before in my example, we really probably need more time. $100,000 in this case, a grain bin to sell corn to deer hunters in bulk so they can fill their deer feeders is our business model. $100,000 to get that built. We need to look at a time plan of 10 years. So these cash flows, they do come from cash flow budgeting, where you look out and see how far out does this business run and what are the estimated net returns, and that's what we're looking at here in cash. All right, so I've got those estimated. Let's look at how do you calculate these numbers. Now the board on our example, we already did this work and I gave you the answers, but how do you come up with these using Excel? Well, an equals formula is going to always be how you start any formula. And in time value 0, it's easy. Present value of 100,000 paid out is 100,000. Now equals, in year 1, we're going to use PV. That's present value, and Excel already has the formula. In fact, if you open parentheses, it'll even start asking you for what are the variables that are needed. Just like the formula on the board, but this is going to do all the math for you. So you go up and choose the rate, 5%. Now I am going to hit a comma, and it asks me for the next thing, which is time, NPER, ends period. That's going to be 1, so I'm going to choose that right there. So I try not to enter the numbers. I try to use cells because I'm going to actually replicate this formula, just copy paste. So these cells are important to have, not the numbers themselves. Otherwise, you got to do the work every time, 10 times in this case. All right, comma. Now the next is asking for a payment. A payment means that within the 1 year, we're going to get several payments. And the answer is no. We get one net value. So I'm going to hit the comma to skip that. The next is future value. Now, when you do time value of money, especially in Excel here, even on a calculator, it's always trying to balance the present value and the future value in equal amount using time and rate. So whatever you have for the variables. In this case, we know the future value, and we need a present value that equals the time and the rate variables. And so there's a positive and a negative. It's always doing to balance the equation. So one of these values needs to be negative. So the other value I get for the answer could be positive. So what I do is I put a negative sign in front of the value I know in my formula. That way, when I close the parentheses and hit enter, it gives me the positive answer I need. So 12,500 today. If you've got to wait a year, really today, it's worth 11,904. Now that formula that I did, I'm going to pretty much just copy and paste it all the way down. So I hit double click so I could see what those variables are. They're all pieces of data in here. Now the only one I don't want to move is that rate. I don't want it to go from C2 to 3 to 4 to 5 when it moves down. So what I do is I go up here and put a dollar symbol in front of that variable 2. I don't want that row to become a 3 and a 4 and a 5, so a dollar symbol just locks that formula. Kind of a trick with Excel. All right, now I've got my formula done. Pretty much just copy and paste, and the next year is 19,954. Then it's the same 21 we had on our example, and 20,000. I just go all the way down, and there they all are. Now, as far as the analysis we did on the board, we stopped at year 5. So if you come in here and just do an equal sum, $100,000 across those 5 years, that's that negative 6,388 from a net present value. So all the present values added up, that's called net. That's not actually a good investment. But if you keep going through all these other years, let me just total that up, you end up with $52,000 that's positive, and that is going to be the net present value. So this is a good decision if you're looking at these values over 10 years. So it's a good decision over 10 years. All right, now net present value is positive, and we're making an additional extra $52,000 above the initial investment and the rate that we were asking ourselves to make. So what is the internal rate of return? Well, we can do equals IRR. And we can say, well, and you got to go back to your original cash flow. That's kind of a mistake in Excel. These are the present value numbers. You need to go back to the original number. And if you give $100,000 for internal rate of return, and then you bring back all those positive cash flows across, it knows how many years because of the rows, that is actually a 15% rate of return. So you required it to earn 5. It applied a 5% required return across 10 years, and there was $52,000 extra dollars. Definitely means we're earning more than the required 5%. What is that? It's 15.04%. So that is the internal rate of return. Now, I did these one at a time and then added them up, very detailed. Or really, if you're using Excel, you don't have to do them individually. You can just do NPV, and that's another formula it knows, asking first for the rate. Well, I want to discount that at 5%. Comma, and then notice it asks for value 1, 2, 3, and it keeps going. So what you do is you highlight value 1, 2, 3, all the way out to 10, and you hit enter. And really, oops, I made a mistake. You're supposed to use those NPVs. Those wouldn't be there. You'd be using your cash flows. So there we go. Now I hit enter, and that's $152,000 net present value, but actually we only had $52,000 here. What's the difference? Well, I don't have factored in. I got to add it because there's no discount. There's no adjustment. That $100,000 I paid up front, I add that back in. So there we go. So there's 2 ways to do this in Excel. One, you can do it one at a time, or you can actually do it here individually, and I think that's a good way to illustrate what those examples are, but the results are the same. This is a good investment. Now, really quick, why would you use Excel to do this? It's one of the tools. Hopefully now you understand the idea of net present value. It's the total of all the present values, including the investments you have to make to get this done. Well, you can look at these things and change lots of variables really quick. Let's say if we kind of looked at the risk of this and said 5% is really not a required enough return. Let's bump this up to 8% required return. Is this still a good answer? Well, we already know net present value is positive at 5%. Internal rate of return is 15. So this thing's earning 15. If you require it to earn 8, it's still a good investment. If you require it to earn 12%, meaning it's really risky, we need this thing to be a better investment for us. Is it still a good idea? Still positive. These are going to keep being positive because it's earning. We already figured it out, 15%. But if you come in here and say, man, this thing is super risky. I don't know if deer hunters are going to come. I don't know if I get the right corn, the quality they need. There's other products out there. This is super risky. What if we need this to earn 20%? It's not going to make it now. You're negative here because it's earning 15. We already know the answer to this. So internal rate of return is a real helpful tool by itself to look at this. A couple of other things we might do, and we've used Excel for this, we might come in here and say we have miscalculated what it costs to get this thing built. We really now have bids in. This thing's going to cost us $150,000 to get this thing built. If you just change that one initial investment, it updates the whole sheet, and guess what? It's still positive by $2,500. Now, however, it's only earning 5.36%. You required it to earn 5. It's earning a little more. Is this a good investment? Absolutely, still good. It's still positive. It's still earning you more. Now, it's only earning you 5.36%. If you looked at the risk of this higher cost, you might say, well, we need it to earn a little more now. We already know the answer. It's not going to earn that. It's not a good investment. But at 5% and at a $100,000 investment, $100,000 investment, the answer is positive. Hopefully this application of Excel in time value of money and net present value helps teach the concept. Hopefully the notes that we talked about on the board really are the concept. How you make decisions as a manager is really kind of the purpose of net present value and internal rate of return. It's a tool using time value money calculations. Hope this helps. Thanks.